The future of mobility promises seamless integration across various transportation types and channels, as well as blockbuster sized economic benefits based on time efficient autonomous systems and increased safety. Not only does it change the way that we and our goods travel, it also reshapes how we think about asset utilization and ownership.
Advances in mechanical engineering, computing, and connectivity allow us to paint a bright picture of your future journeys on the road, in the air, and even underground. Let's explore.
Welcome to the UTX podcast, where we bring you a utopia created by technology, presented by your Techniax. I'm Ani.
And I'm Val. And today's Utopia features future mobility technologies, such as mobility as a service, the future of aviation, and unmanned aerial vehicles, which include drones, as well as Hyperloop and underground transportation systems.
In combination with episode 3 on autonomous vehicles and episode 10 on 5G and the Internet of Things, this episode gives you the full picture on what the future of mobility will look like and how we get there by overcoming the challenges ahead. Let's dive into it.
All right, first of all, we would like to look at the future of mobility from a conceptual point of view. And we think that mobility as a service, which we will explain further in a second, is the guiding principle or the guiding concept behind all of those technologies that we see. It sort of integrates all those technologies. If we have today as the starting point, today mobility solutions, both public and private, are limited by disintegration and missing customization. The concept of mobility as a service, which we will probably shorten as MaaS to not bother you with it all over again, proposes to connect public and private transportation across the full spectrum, from bikes and scooters to shared cars, buses, trains, and even airplanes, to create a user experience of an on-demand, personalized, seamless, and highly efficient journey for everyone.
Now, the underlying premise of MaaS is the sharing economy. Now, the sharing economy proposes to organize private transportation as a pay as you go service, much like Uber, instead of private ownership of transportation assets like we've known it with cars. Privately owned cars are unused for about 95% of the time, and they just occupy parking space. In 2017, Deloitte went as far to say that by 2025, private car ownership might become obsolete. And we are witnessing an emergence of more and more car, bicycle, scooter, and even ride hailing platforms, which are currently being integrated with public transportation in various places.
Next to all those sharing services, another major premise and booster of these MaaS concepts are autonomous vehicles. These AVs increase efficiency because they relieve the user of timely burdens, including driving the car, finding a parking space, or waiting in the traffic jam. To get the full picture on the future of mobility, make sure to also have a look or listen on to episode 3 of our podcast, which is about autonomous vehicles.
Now, or another concept that underlies MaaS is a so-called joint digital journey planner that would be like a smartphone app where the user can interact with the app to plan, book, and pay for door-to-door multimodal journeys. Now, seamless integration and simplicity allows the authentication with digital ID and also allows payment for the full trip at once using convenient payment technologies such as contactless payments. Now, the platform would also have to offer potential for further integration, for instance, on the fly omni channel grocery shopping, meaning you would order groceries while on the move and collect them during transfer at a central hub like a train station or a bus station.
This whole idea of a journey planner has been around since 1996 and has been thought of for a long time. The idea is that the user can check multimodal door-to-door connections and select the best one fitting their needs. Be those main needs, be it timeliness, cost, convenience, or even eco-friendliness, or a combination of those.
Now, finally, there's even already an example that exists in Finland called Whim. Now, the app Whim allows users to create personalized journeys by integrating public transport options with city bikes, e-scooters, taxis, ferry tickets, and rental cars. Whim offers the user to pay for one trip at a time or to just purchase a monthly subscription.
So during your journey in the future of mobility, you should be able to be fully connected, meaning that during your trips, you have access to internet connection, as well as entertainment and productivity options, which you can instantly book and administrate with your digital device, allowing you to use your time on the road efficiently.
And in the back end, the demand and the journey data from users could be used to make transportation more efficient and sustainable. So you could, for instance, have predictive algorithms to anticipate peaks or lows in demand and thus adjust public transportation capacity and schedules accordingly. Or they could even intelligently route individual vehicles through certain paths to prevent any traffic congestion.
And this is not where the benefits for the public end. Society as a whole could also benefit from improved utilization of the public transport network. As you already mentioned, reduced traffic congestion is another benefit. Another benefit is increased efficiency of transportation and reduced emissions overall.
Now, MaaS is going to do much more than just benefit society. It's also going to disrupt major industries and governments. Now, experts say that governments will miss out on past revenues from taxation on private cars, fuel tax, and fees for road enforcement tickets because these will all not be of relevance anymore. Also, the need for car insurances, as we know today, will vanish. So, this would force insurance companies to rethink insurance mobility and risk models in new and innovative ways.
Yeah, there remain several challenges, however, when it comes to slowing down the adoption of such a MaaS concept. And as you might guess, COVID-19 didn't help a lot. It also represents a setback here in a sense that it reduced the demand for public and private mobility and really has slashed the revenues in the sector, which obviously also slows down developments of new partnerships and technical integration.
And speaking of technical integration, another point is to have a sort of central digital hub to create a one stop shop for customers. And to do this, MaaS requires not just new ways of industry collaborations, such as public private partnerships, but also the integration of various mobility solutions and other aspects, such as booking and payment solutions.
Now, let's say that you have a strong willingness from collaborating parties. This still is a non-trivial problem because questions regarding data privacy and data sharing remain. For MaaS to work, you need to have data accessible, for instance, on all available services, all ride schedules, delays, trip duration, and pricing. Access to access to partially proprietary data on algorithms, timetables, and routes is needed, as well as personal data around authentication, location, and rides. All of this needs to be shared in order to frictionlessly enable these services via a mobile app or similar to the end user.
Now, one way that you could solve this would be to use so-called homomorphically encrypted data. Now, to learn more about what that means and how it could push the future of AI, check out our episode 13 on the future of machine learning, specifically on the future of computing. Now, another challenge is that for or to providing additional connectivity to public infrastructure is another big requirement so that MaaS can work flawlessly. And this would mean new investments. However, these infrastructure budgets are planned for the long term, and cycles of infrastructure renewal are not as quick, and for good reasons.
And another challenge remains regarding providing these services to the elderly generation and in general integration of those services cross-channel. So this means that booking, ticketing, and payments should not just work online, but it should also work offline. And more importantly, it should be seamless cross-channel. So if I start a booking process offline, I should be able to trace that online, could be a QR code, for instance, continue, do my payments, and finish the booking process.
Now, we've taken a look at the concepts of mobility as a service and how it would revolutionize, but that's not the only area where there will be changes compared to today in tomorrow's mobility. Another important aspect are technologies, and we're, of course, looking at technologies apart from autonomous vehicles. So let's look at which technologies, which innovative transportation technologies are primed to additionally enhance the future of mobility by offering many further options in the air or even underground.
And first, we look at drones, or more generally, so-called unmanned aerial vehicles, or UAVs. And these initially emerged from the military, like so many innovations. They were used to complete risky operations in dangerous remote areas. In the meantime, however, drones have become popular for applications in media, so for photography and video shooting, as well as logistics for drone deliveries, as well as agriculture. You should have seen some videos of drones monitoring crops, and also for infrastructure and environmental monitoring and surveillance. Drones can either be fully autonomous or remotely controlled, as sadly it happens a lot in military applications. Drones are usually composed of rotary wings, lithium polymer batteries or hydrogen fuel cells, depending on their size, a circuit board with microprocessors, position and movement sensors, inertial measurement units, gyroscopes, and accelerometers. And if this sounds a little bit Spanish, if this sounds a little bit strange to you, then you should definitely check out episode 3 on autonomous vehicles, where a lot of these technologies are also built in to help the AV navigate and drive. What's more, there is actuators like servo meters for control of speed and direction, and there is autopilot software as well as a broadband radio link for connectivity.
Now, UAVs can take the form of small and medium-sized drones, but there are also the military drones that have a special name. They're called vertical takeoff and landing, or so-called VTOLs. And as the name suggests, they can take off, hover, and land vertically. And this definition, of course, would also include rockets, helicopters, and in the future, potentially even aircraft. There are even some today, like the Osprey, which has jets that can turn vertically. So this might also be part of the future of mobility.
Now, a quick look into the market. And we distinguish between the military drone space and the civil drone space. So historically, from the military drone space, the US and Israel, as you could guess, are dominating that. However, in the civilian drone space, things look much different. China is the leading manufacturer, and there is one specific company which is based in Shenzhen, and it's DJI. It holds, or DJI, and it holds an unbelievable 70% market share for consumer drones in 2020. One company, 70%. The global UAV market is expected to reach $22 billion by 2021 in this year, and the civilian portion of those is 5.5 billion in 2019. So the
DJI has 70% of that 5.5 billion.
Exactly.
That is crazy.
In 2019, it was even more than that. So historically, the military drone space is still quite large, but with increased consumer adoption, this is changing. Morgan Stanley projected that the global market for autonomous urban aircraft could reach 1.5 trillion by 2040. The R&D budgets for the space are also expected to greatly increase in the future. In 2028, we expect them to be $4 billion, while 8 years later in 2036, they're supposed to be already 30 billion US dollars.
And this is obviously reflected in the increased responsibility which drones are expected to carry in society. Now, short haul, kind of unmanned logistic flights outside of cities are expected to happen as soon as 2025. Now, long haul cargo flights, hopefully by the mid 2030s, and passenger flights by 2040. And that's just 20 years away. So we are definitely looking forward to that.
And while we do look forward, there are some remaining challenges. Major challenges that drones face are related to safety and security. Consumer drones have represented a threat to air traffic in the past. They have collided with aircraft, they've interrupted airspace, and they distracted pilots and air controllers multiple times before, which is why regulations regarding the use of them remains quite tight. You see them forbidden near airports and near critical air traffic infrastructure, and either the use of larger sized civil drones is either forbidden or you need to register them. Also, unmanned aircraft traffic management systems, or UTM, have been or are being developed by several regulatory bodies to have better means of monitoring air drone traffic.
Now, this is an uneasy one to say, but drones can, of course, also be used as weapons for terrorist attacks by being loaded with hazardous payloads or simply just crashing them into vulnerable targets.
The extensive connectivity of those unmanned aerial vehicles makes them more vulnerable to hijacking incidents by hackers because they are connected and you can interrupt the network traffic, which is a difference to classical aerial vehicles.
And another challenge is energy efficiency. Now, currently, to carry a significant payload over a distance of 30 kilometers, researchers calculated that a drone would need half as much energy as a truck. And that's still not as efficient, but hopefully as batteries improve over the years, the energy needed could halve again to a quarter of the energy that a truck would use. So that is a bit better. However, batteries are also required to discharge faster. This could cause them to heat, possibly even catch fire, and this would also reduce their lifespan. So you would also need to have specialized cooling systems that would be implemented for longer distances or heavier payloads.
As with many technologies that disrupt industries or whole societies, there is some kind of notion to it when it comes to public perception, a certain stake. And consumer perception and social acceptance is a key challenge for drones as well. It will take some time for consumers to adapt to the thought or the idea of taking an autonomous drone through a city congested by air traffic.
But let's take a look at some of the examples or already existing use cases of UAVs and even flying cars that are being developed and deployed for transportation and logistics. So the first one takes us all the way to the city of Seoul, where in November 2020, they demonstrated a show flight of a two-seat drone helicopter taxi that was built in China. Now, the drone taxi completed its 7-minute flight without any issues, but also without any passengers yet. But the South Korean government plans to commercialize autonomous air taxis by 2025. And this includes a K-drone air traffic management system for drones. So drone taxis could relieve traffic congestion, cut urban transportation times by up to 70%, and even help with decarbonization. The price for such a drone flight appears initially expensive, with about $100 for a 50-kilometer trip, but this could be cut down to $20 according to the South Korean ministry. The event in Seoul, interestingly, also featured presentations of several smaller unmanned package delivery drones.
We've spoken a lot about China as the main manufacturing space of civil drones, and also the example of Seoul that Ani just mentioned is built or works based on drones built in China. But there's also examples of pioneers from other regions of the world, with the German company Lilium just having secured $375 million in funding. It employs more than 500 people, and it has developed a 5-seater electric VTOL jet. So remember, VTOL means vertical takeoff and landing. The device, powered by 36 electric motors, can travel 300 kilometers in 1 hour on one charge. So that's its reach, its span. The motors provide, or its range rather, the motors provide vertical thrust during takeoff and directional impulsion during flight. Talking about its manufacturing process and operation, the aircraft has about the same number of individual parts than a family car. The device is inaudible if it flies above 400 meters and is only as loud as a truck when it takes off.
Now, another player in this industry that we thought is worth mentioning, because there are many others that we unfortunately couldn't get to, but this one is Uber, and they've long planned to launch their Uber Elevate aerial ride-sharing service in the US and Australia by as soon as 2023. They also had a partnership with Hyundai to mass produce a 5-seater drone vehicle, so kind of similar to the one that Lilium developed today by 2028. Previously, Uber also operated the so-called Ubercopter, which was a helicopter ride-hailing service in New York, which allowed users to get to JFK Airport, which could be very helpful because getting to JFK Airport can take a long time. Now, the Ubercopter was also introduced to other large metropolitan areas. However, the eVTOL manufacturer Joby Aviation is currently acquiring Uber Elevate after the companies have been working together since 2019. Now, Joby and Uber aim to integrate each other's services of ground and air transportation and to accelerate their launch schedule by the acquisition and subsequent partnership.
Now, while drones are very promising, for them to be used on large-scale consumer applications, meaning your typical flight from New York to Los Angeles or from Barcelona to Paris, or rather, I mean, Barcelona to Paris, rather not, but let's say Barcelona to Moscow, it still takes some time, maybe 20 or 30 years is what experts say. So let's look at how aviation and aircraft are changing anyways. What are the main developments in there? And we argue that we should focus on two today, which is the developments of new carbon neutral fuel types, as well as the developments of new robust aerodynamic and lightweight airplane materials.
So let's take a look at these new fuel types, so-called electrofuels or e-fuels or synthetic fuels, which are made of synthetic gas or hydrogen, as well as biofuels such as biodiesel. All of these could make airplanes more efficient and reduce emissions. Electrofuels are carbon neutral and make use of energy stored in chemical bonds of liquids or gases. For more information on new fuel types, feel free to check out our last episode on the future of energy.
Two spin-offs from the ETH of Zurich, Synhelion and Climeworks, are developing net zero emission fuels. They are net zero because during production they capture carbon dioxide. They do that by using a hydrocarbon, which is made out of carbon and water, as well as solar power in a thermochemical reactor to create a so-called syngas as combustion fuel. Now they are net zero because they still do emit some carbon dioxide during operation. However, they are working in collaboration with Lufthansa already to have these fuels ready by 2030. So that's a good example for such a new type of fuel that is actively being developed by an industry giant in the aviation space.
These green fuels are a viable alternative for electric airplanes. This is because batteries are still very heavy and based on very low energy density in the batteries. In fact, jet fuel contains about 14 times more energy per weight unit compared to current lithium-ion batteries. What is challenging about the development for aviation fuel types is that they need to be compatible with existing engines and fuel types and need to adhere to existing standards.
Not just to existing standards, but they also need to break existing market dynamics. Whatever fuel will be used in the future needs to become cheaper than existing jet fuel types like kerosene. Further regulation in the space will be needed, such as promotion and implementation strategies by regional authorities, subsidies and grants for the development of these fuel types, and increased cost of carbon dioxide emissions.
So now we move on to the other innovation that we mentioned in this space, which would be the development of new robust aerodynamic and lightweight airplane materials. Now, the innovation of aircraft materials happens in very slow cycles, and this is due to the fact that once deployed, capital and aircraft are in operation for decades. But also due to the high requirements towards materials, they need to be robust and corrosion resistant and simultaneously be very lightweight.
Modern aircraft today are made about half from robust but lightweight carbon fiber composites and about half from aluminium and lithium, titanium, steel, and other metals. In 2015, Airbus additive manufacturing arm called AP Works has released a new aluminium magnesium scandium alloy, which can be used in metal 3D printers deploying the technique of selective laser melting or direct metal laser sintering.
You mentioned 3D printing, so we also have to mention 4D printing, and Airbus is indeed experimenting with 4D printing technologies. 4D printed smart materials can change the shape depending on changes in outside conditions such as air, moisture, and thus they could replace heavy mechanical control systems in the aircraft. If you're excited about these material innovations and 3D as well as 4D printing, you should definitely check out our episodes on that topic, episode 7 on 3D printing and episode 15 on 4D printing.
We've taken you high up in the air for long distance traveling, but there's also underground transportation that defines the future of short and medium distance traveling. More specifically, there is the Hyperloop. The idea of the Hyperloop is to transport people over medium distances, around 1,000 kilometers, in high-speed magnetically levitated trains, or so-called pods, operating in partly evacuated, so airless, tunnels or tubes. Under high-speed circumstances, vacuum and magnetic impulsion have significant advantages by eliminating friction and air resistance. Both tube transportation systems and also high-speed trains operating on magnetic levitation are nothing new. They exist already. But the combination of these two concepts is new, and this is what makes the Hyperloop exciting.
In fact, the concept of a vacuum train was proposed way back in 1904. And in modern times, it is, of course, a brainchild of Elon Musk, and he first publicly mentioned it in 2012, and he explicitly open sourced it. And this led to formation of several companies, one of them being Virgin Hyperloop by Richard Branson. And it also led to competitions and interdisciplinary student-led teams from renowned technical universities, such as the Technical University of Munich in Germany or the MIT, to work on these concepts. Musk later named the concepts a cross between a Concorde, a railgun, and an air hockey table. Also, a joint team from Musk's companies, Tesla and SpaceX, they are working on this implementation. And in 2015, they had a 1 mile long test track vacuum tunnel next to the SpaceX facility in Hawthorne, with subsequent competition seeing developments for this technology shoot up.
Let's look at two examples of where and how Hyperloop tunnels and Hyperloop systems are being developed. And maybe to your surprise, Elon Musk's companies are not within those projects. But the two leading companies are Virgin Hyperloop by Richard Branson, as well as Hyperloop transportation technologies called Hyperloop TT. So those two are at the forefront, being the closest to developing a working system, a fully operational Hyperloop system. In November 2020, two Virgin Hyperloop executives were the first ones to ever ride in a Hyperloop in the company's Nevada desert test site near Las Vegas. They completed a 500-meter run in 6.25 seconds. Virgin has raised over $400 million and recently announced a collaboration with the Saudi government to build a Hyperloop in the capital of Riyadh, aiming to build a national Hyperloop network covering several thousand kilometers and allowing one to get from Riyadh to Jeddah in just 46 minutes. Founded 2013 in California, Hyperloop TT is even closer to making the first Hyperloop a reality, despite their a little bit smaller funding of $130 million. They have built test tracks in the Aerospace Valley in Toulouse, France, and in Great Lakes in the state of Ohio. By 2023, their 10-kilometer section between Abu Dhabi and Dubai, so once again in the Emirates and in Saudi Arabia, should be completed in 15 minutes. So you should be able to travel between Abu Dhabi and Dubai in 15 minutes. And in 2023, this could become operational. That is their plan. The first Hyperloop system, however, might be for freight, such as the system that Hyperloop TT is building for the harbor in Hamburg.
Challenges include safety considerations. After all, the Hyperloop operates in a nearly vacuum tunnel at very high speeds with several pods close to each other. Other facts are the impact of fast acceleration to health, the comparably high ticket prices proposed, and the efficiency losses caused by the terminals having to be built in the outskirts of cities.
Those challenges remain, but nevertheless, we are excited about Hyperloop and in general about the future of mobility. The future of mobility will now be explored, as always, in our Utopian day in the life of the Techniax. I wake up, I'm being woken up by my smart doorbell. It rings and alerts me that a package has arrived. I hurry to the window and still see the robo-concierge walk back into his package delivery drone, carried away to deliver the next one. The drone is powered by hydrogen fuel cells and solar power, and it only has a small battery, so it can carry significant payload.
So in the morning, after receiving my package, I realize I have a meeting at the other end of the city. Thank goodness I have the smart travel app. So I open it, and with just a voice command, I automatically get a journey that is completely optimized to my exact needs. The movement sensors in my phone could sense that I haven't slept so well, so the app automatically avoids too much social interaction on the way.
Yet, if you want, you can still share your journey on your social media accounts and activate them during your journey so you can get to know new people. So I unlock my shared scooter and have a ride towards the car sharing station, where I take an autonomous flying VTOL towards the train station, which brings me to my workplace. On board the VTOL, I enjoy some scientific media content, which was automatically selected by a recommender system targeted to my needs.
Now, at lunchtime, I discuss with my colleagues how air traffic has become entirely and truly carbon neutral based on new fuel types which eliminated during production. Also, airplanes have become much more energy efficient based on 4D printed smart materials that remove the need for many systems that are very heavy.
A friend calls me in the afternoon. He sits in a newly established Hyperloop connection from Paris to Berlin. He enthusiastically greets me and shows me around the pod, which takes only 20 minutes for the ride between the two cities.
And after that, it's time to get back home. And I decide, why not drive a car again? So I hop inside an autonomous car which still has a driver function. And I don't fear any accidents because the automatic road traffic platooning system of my cars, of my city's authorities, automatically puts me in check if I should drive faultily. Also, I have no incentive to do so because it would increase my mobility insurance. Now, any entity in the meantime, including scooters and bikes, need to register with the city's IoT platooning network and get connected. Just like you used to register your car with transport authorities way back when people still used to drive cars.
And this wraps up our Utopian Day powered by the future of mobility. This has been UTX episode 17 on that very future of mobility. If you stay tuned, you will be able to see the next episode, arguably on one of the most, if not the most important sectors for society, on the future of education and edtech. You can follow us and see this episode, listen to it, or read it on YouTube, on Spotify, Apple Podcasts, Stitcher, Google Podcasts, as well as on Medium. And did I mention YouTube? Yeah. So on all those platforms, you can consume that content.
We also have started uploading small bite-sized clips so that you can take away the most important segments, the most interesting aspects of our UTX episodes on the go, which can also be found on YouTube. And as always, stay utopian.
Your Techniax.